Okay, I'm going to do another one from the book. And again, I have the old version, so I'm not sure the numbers are right. But this, in my version, is 22 in section 9.4. And this is the one labeled Google It. So if you look for that one, you'll find it. Okay. So a marketing research company, blah, 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 reported 95% of online searches use Google. A network administrator wants to see if that's true in his company, so he samples 400 searches. So N is 400. And finds 295 of them use Google, so that's the number of successes, 295. Can he conclude the percentage of searches that use Google in his company differs from 65%? So the question, can he conclude the percentage is different from 65%? Right, and it says use alpha equal 0.05. Okay, step 1, set up the hypotheses. Whatever's in this can we conclude question, that's what goes in the alternative, right? This is always the alternative. So it's a mean or proportion. Started to say it was a mean. See, and then I turn it into a question, which makes it seem like I'm, yeah, okay. It's a proportion. Oh, and I'm getting really tired of making videos. The proportion is different from 0.65. The opposite of that is that the proportion is equal to 0.65. All right, step 2. It's a proportion, which makes this a z distribution, always. And we've got alpha equal to 0.05. And the alternative hypothesis is not equal to, which means this is a two-tailed test. So we've got 95% in the center. Right? We've got 0.025 out here in each tail. And these critical values are negative 1.96 and positive 1.96. And if you don't believe me, you can look those up in a table, or you can use inverse normal on your calculator to find those critical values. I think my daughter is also getting tired of making videos. Okay, step 3. For proportions, we have a lot of stuff to check. Is this a good random sample? Are there only 2 outcomes? Oh, I'm like checking them off without thinking about it. Sorry. Population. 20 times bigger than N. And I need at least 10 in each category. All right, now instead of just automatically checking them off, let's go back and look at the problem. It says he samples 400 searches. It doesn't really say that it's a good random sample. Right, so I shouldn't have checked that off because we really can't tell by what it says. Only 2 outcomes. This is true. It's just whether it's Google or not. Population 20 times bigger than N. Well, he sampled 400 searches, right? N is 400. So we would need our population to be 20 times that. We'd need his population of 8,000 searches. Are there 8,000 searches done in his company? It doesn't say. And there's really no... It's really even hard to tell how big his company is. So we really don't know. Here's another one, right, where we're not sure. At least 10 in each category. Well, now that's true, right? We had 295 searches that used Google, so we've got 105 that didn't use Google, so that works. But we're really not sure if our population is big enough. We're not sure if this is a good random sample. Even though we're not sure, we're going to keep going just for the practice. So, step 4. We're going to put it in the calculator. So, 1 prop z test. Again, because it's a proportion. And on my Casio, I'm going to put in not equal to. P sub 0 is the value in my null hypothesis, so that's 0.65. The number of successes is 295. The sample size is 400. And so at the top, I should have mentioned this before, right? It says prop not equal to 0.65. This is my alternative hypothesis. And it wrote out prop instead of just a p so that we wouldn't get confused with p-values and all that kind of thing. So this does match my alternative hypothesis, and so that's good. Z is equal to 3.67. The number under that is the p-value, 2.435 times 10 to the negative 4. And then p hat is under that. That's x divided by n. Okay, so step 5. Our z-score puts us out at 3.67. So we're out here, right? 3.67 standard deviations away from the mean. So we're in the rejection region. 3.67 is greater than my positive critical value. So we reject. And P is less than alpha. If P is low, we reject the O. So step 6. Can he conclude the percentage of searches that use Google in his company differs from 65%? Yes. He can conclude the percentage is not 65%. But step 7, do we have some concerns that he did this correctly? Yes, we do. This might not be a good random sample. And the population might be too small. Let's take a break.